Welcome to this explainer. Today, we are going to completely demystify the architecture behind hyperconverged infrastructure, or HCI. If you've been working in or even just researching the modern data center world lately, you know HCI has totally transformed how we think about scale, compute, and storage. It's a real game changer. But look, we are just going to throw high-level marketing buzzwords at you today. No way. We're getting right down to the bare metal and the code. Let's unpack this whole shebang together and see how it actually works.
So let's kick things off by literally opening up the box. What exactly is inside a modern HCI node? It's really easy to think of hyperconverged setups as these abstract floating cloud concepts, right? But in reality, they rely on some incredibly robust, highly engineered physical gear sitting in a rack somewhere.
Here's our roadmap for today. First, inside an HCI node. Second, the controller VM magic. Third, a real-world Nutanix example. And finally, hybrid versus all-flash storage.
All right, Section 1. Inside an HCI node, the hardware foundation.
Inside these standard 1U or 2U rack mount chassis, which by the way can actually hold up to 4 nodes in a single 2U space, you're going to find some serious enterprise-grade hardware. We're talking dual CPUs and a massive amount of DRAM to handle those intense compute loads. For local storage, you'll see a mix of drives, varying from your standard SSDs and HDDs all the way up to ultra-fast NVMe. But hey, compute and storage are just part of the story. You've also got onboard and PCI network interface cards, plus a baseboard management controller, which is absolutely crucial for out-of-band management. And to wire all this together, you get massive redundant network uplinks pushing 10, 25, 40, or even 100 gigabit Ethernet straight into your top-of-rack switches.
Now, sitting right on top of all that beautiful physical hardware is your hypervisor. Whether your environment is running AHV, ESX, or Hyper-V, this acts as your foundational virtualization layer. It runs directly on the metal, seamlessly translating all that raw physical power into resources that your virtual environments can actually consume and utilize.
Moving right along to Section 2, the controller VM magic, the software brains.
Okay, so how does the system actually handle all that physical storage we just looked at? Enter the controller VM, or the CVM. This is a very special virtual machine that runs on every single node. What's wild here is that the CVM actually bypasses standard virtualization using PCI pass-through, basically direct disk access, to take absolute ownership of those local physical disks. It then actively participates in a massive distributed storage fabric with the CVMs on all the other nodes in your cluster.
Building this into a fully converged system happens in 3 key steps. Step 1, the CVM owns the local disks. Step 2, these CVMs connect and talk to each other across the nodes. And step 3, and honestly, this is the real genius of the whole architecture, storage and VM traffic share the exact same converged network. By having the CVMs communicate over those same massive network uplinks as your standard VMs, it completely eliminates the need for a separate, messy, and super expensive storage area network. Everything just rides that one unified fabric. Section 3. Real-world Nutanix example, grounding the theory.
Let's anchor this with the Nutanix NX8155G8. It's a perfect specimen of a modern node packed into a highly compact 1U form factor. Under the hood, it's rocking those dual CPUs we talked about, incredibly fast NVMe and SSD storage tiers, and redundant power supplies just to keep things highly available. It's essentially a dense, high-performance powerhouse designed specifically for the modern data center.
But here is the catch. You don't just buy one of these things and call it a day. It takes exactly 4 of these powerful nodes to form a standard starter cluster. Why 4? Well, that 4-node minimum ensures you have the proper distributed storage fabric, the necessary fault tolerance, and the aggregate compute capacity to actually run a highly resilient, hyper-converged environment.
And that brings us to Section 4, hybrid versus all-flash storage, architectural choices.
The physical difference between these two design patterns is pretty stark. On one side, hybrid storage gives you a mix. You get extent-store SSDs acting as your hot performance tier and write buffer, paired up with traditional hard disk drives that serve as a cold, high-capacity tier. On the other side, all-flash storage just completely ditches the spinning disks. It relies exclusively on SSD or NVMe across the entire storage pool to give you maximum possible performance.
Now, if you go the hybrid route, you're probably wondering how the data ends up on the right type of drive. That brings us to Information Lifecycle Management, or ILM.
For hybrid nodes, this ILM software is the absolute magic handling data tiering behind the scenes. It automatically keeps your frequently accessed, hot data right there on the fast SSDs, and then, completely silently, it down-migrates your cold, infrequently accessed data to those high-capacity HDDs. You don't have to manually drag files around at all. The system is constantly optimizing itself.
Understanding the business trade-offs here is absolutely critical. If we look at cost efficiency, hybrid definitely wins on cost per gigabyte of overall capacity. But all-flash wins on cost per IOPS, giving you maximum input/output operations per dollar. When it comes to latency, hybrid is kind of variable, depending on where the data sits at any given moment, whereas all-flash delivers consistently low latency across the board. So what does this actually mean for your workloads? Well, hybrid is fantastic for large, less latency-sensitive data sets, like file shares, backups, and archives. But you absolutely need all-flash for those performance-critical tasks. Think high-transaction OLTP databases, or surviving brutal VDI boot storms when hundreds of users are logging into their virtual desktops at exactly the same time.
Which brings us to a final thought I want to leave you with today. If all-flash easily handles your intense VDI boot storms and mission-critical databases, what forgotten, unoptimized data is quietly migrating down to your cold hybrid tiers right now? It really makes you wonder how your own data lifecycle is being managed, leaving you to question what exactly is sitting on your high-capacity drives today. Thank you so much for joining me for this explainer. I hope this helped demystify the architecture for you, and I'll see you next time.